The Liskov Substitution Principle states that objects of a superclass should be replaceable with objects of its subclass without affecting the correctness of the program. So this principle ensures that inheritance hierarchies are well designed and that subclasses adhere to the contracts defined by their superclasses. And violations of this principle can lead to unexpected behavior or errors when substituting objects, making code harder to reason about and maintain. So this is very confusing, so let's consider an example involving a rectangle class and a square class which inherit from a common shape class. And initially this is going to violate the Liskov substitution principle by not adhering to the behavior expected from these classes, and then we'll fix it to ensure that the principle is respected. So first of all, we're going to create a shape class, and this is going to be an abstract class. This is going to sit at the very top of our sort of shape class hierarchy, and we're going to create a public abstract property for area. And so all shapes should have this area property. So next up, we're going to create a concrete implementation of our abstract shape class. So we're going to create a rectangle class, and this is going to inherit shape, and then we can press Command full stop, implement abstract class, and we can see VS Code automatically implements this area property for us. So if we look at a rectangle has a width and a height. So let's add properties for width and height, because we need those properties to be able to calculate the area of the rectangle. And the area of a rectangle is very simply just its width times its height. Okay, so that's a rectangle. We're now going to create a square class, and this is where things get slightly more interesting, because the way we're going to implement this square class is we are going to extend or inherit from the rectangle class. And why are we doing this? Because, well, a square is mathematically just a special type of rectangle where the width and the height are equal to each other. Okay, so that's our line of thinking. We're just thinking, right, a square class is a special type of rectangle, a square is a rectangle, so let's actually inherit the rectangle class. But we need to make a few modifications, because if we set the width on a square, then we need to make sure that it's equal to the height. And if we set the height on a square, then we need to make sure that the width is also set equal to the height, so that the side lengths are always the same and a square always remains square. So let's actually do that. So what we can do is we can override the width property, and we can say that the getter remains the same. We just return the width, the base referring to our base class, which in this case is rectangle, and then we can update the setter so that the base.width is equal to the base.height, which is equal to the value that we are setting to. Okay, so the width and the height are always going to be equal. And then we can do the same for the height, and I'm just going to save a little bit of time here and copy and paste that in. So as you can see, the getter just returns the height, and when we set, we also set the width equal to the value that we are setting to. Okay, so a square always remains square. Okay, so now what we're going to do is we're going to write a test. And in the test, what we're going to do is we're going to make sure that our program is calculating areas correctly, or as expected. So we're going to create a rectangle, and we're going to set the rectangle's height equal to 10. And we're going to set the rectangle's width equal to 5. And then we can say that the expected area is going to be equal to 10 times 5, which equals 50. Okay? And then we can log the actual area that the rectangle calculates by calling rect.area. So if we run this program, we can see that the expected area is equal to the calculated area, and this test passes successfully. But now if we look at the Liskov Substitution Principle, objects of a superclass should be replaceable with objects of its subclass. So the superclass in this case is rectangle, and a rectangle subclass is square, because a square is a subclass of rectangle in this case, right? It inherits from rectangle. So, according to the Liskov Substitution Principle, we should be able to substitute a rectangle for a square, and our program should still be correct. So let's see if that works. So we substitute it for a square, run our program, and we can see that the expected area is 50, but the calculated area is 25, because when we set the width, it also sets the height to 5 as well. So then when it calculates the area, it's going to be returning height times width, which is 5 times 5, which equals 25. And this is not what we expected. So we are here violating the Liskov Substitution Principle. And you can kind of see how this makes it easier for our program to contain bugs, because if we treat a square as a rectangle, which according to our code we should be able to, we shouldn't get any errors, but we are getting errors. This test no longer passes. So let's refactor our program to satisfy the Liskov Substitution Principle. So what we are going to do is we're going to modify our square class so that it no longer inherits from rectangle. Okay, so what we're going to do is we're going to inherit from shape. Okay, we're just going to say a square is a shape and not a rectangle. Okay, so in a square, really, it doesn't really feel very correct to store width and height properties on a square. It doesn't really make much sense, because a square just has a side length, and all the side lengths are equal. It has 4 sides, and each side is an equal length. So really, we only need to store one property called side length. So if we create a public property for side length, and also we can see here that we are getting an error because we need to implement this shape abstract class by providing an area property, and the area is just going to be the side length squared, or the side length times the side length. Okay, so we now have a rectangle and a square, which are both shapes. They both inherit the shape class. So now let's create a test for our square and rectangle. So what I'm going to do is let's comment this out for now, and we'll create a new test. So we're going to just say shape rectangle equals new rectangle. And I think what we'll do actually is we'll just set the width and height when we create the rectangle, just to save a little bit of a few lines of code. Okay, and then what we will do is we will log the area of the rectangle. Okay, and then what we'll do is we'll also create a test for our square class. And as you can see here, both rectangle and square are shapes. They are classes of type shape. And we're going to create a new square, and we will set the side length equal to 5. And then we can say area of the square is equal to square dot area. Okay, so here we're expecting 25 because 5 times 5 is 25, and above we are expecting 20. Okay. Okay, perfect. So now what we can do is we can essentially we've redesigned the square class to directly set the side length. So now a square is correctly modeled as a subclass of shape, and it adheres to the Liskov Substitution Principle, because now all shapes are substitutable with each other, and they calculate their areas correctly, okay, or as expected. So how does this satisfy the Liskov Substitution Principle? Well, we've created a superclass called shape and subclasses rectangle and square, okay, and both rectangle and square maintain the correct expected behavior of a shape, and in our case that is providing an area, and they should both behave appropriately when interacting with other parts of the program that expect shapes. So we can now treat rectangle and square as shape of type shape, and they both always calculate areas as we expect them to. The expected area of a square here, I mean, we haven't logged what the expected area is, but we could log that the expected area is going to be 25, and here we could log that the expected area is going to be 20. Okay, and whatever we change the side length to, whatever we set the side length to, it's always going to give us the correct area. Okay, so shapes now are always going to return the correct area. We have no problems with substituting shapes with other shapes and then calculating their areas. Okay, so now we are satisfying the Liskov substitution principle, and our program is less error prone. Okay, less prone to introducing bugs, and less prone to unexpected behavior.